everyone. Today we'll work on LeetCode problem 1425, the constrained subsequence sum. So let's first see what this question is about. So we're given an integer array nums and an integer k. For example, nums is this array and k equals 2. And we are required to return the maximum sum of a non-empty subsequence that this array every two consecutive integers in the subsequence satisfy this condition. This means the I and j are actually the index in the original array. And this means that if we delete some number between I and j, the deleted number should not exceed a certain value. For example, if we deleted k numbers, then j minus k will be equal to k plus 1, will violate this condition, right? So here are some examples, and I think we do not need to walk through them one by one, and we'll directly go to how to solve this problem to save some time. So here are the constraints. So the number of elements in this array is on the order of 10 to the 5th, and k is a similar order. So this means if we want to solve this problem, we need to use either n log n or O(n) time to complexity to solve it. And this constraint indicates that there are also we have positive and negative values inside this nums, and they are not very large. So this number times this number does not exceed 10 to the 9th, so we can use int to represent this value. Then how to solve this problem? So actually we can easily find out a naive dynamic programming method if this number length is very small. For example, if suppose we do not consider the time constraint, we can use an n-squared algorithm to easily solve it. So ij is just to, for example, we define the status ff, and fi is for the array 0 to I minus 1. For array 0 to I, and we will remember the maximum value satisfied in this question. Okay. The requirement. Then, in order to calculate fi, we need some computation to determine it. For example, we need to loop over for j equals I minus k plus 1 all the way until j equals I, right? And then we compare fj plus nums I and find out the maximum. Get the max. Right, this is a naive way to do it. However, if you want to do it, you need to loop over k items, and k is also on the order of nums length. So this is n² time complexity. So how to optimize it is actually the key point in this question. So there are two ways to optimize. One is if we have we maintain a DQ, which is a monotone, the decreasing array. Or another way is to use a priority queue, which maintains the max element on top, right? So we can either use a a decreasing array or use a priority queue to solve this problem. And this will give a time complexity of O n, and this will give a time complexity of O log n and n log n. So both will be able to pass this the online judge. However, we will choose this one because this is has smaller time complexity. Okay, so we'll define a DQ, which is Q, and every element is the index in F. Remember, this means the index in F. And then we define the dp vector F, which is 0 initialized, and we loop over all the elements minus I less than n plus I. Then actually we need to define the return value. It should be int min at first. Then first, remember that we need to maintain this queue to be decreasing, and also we need to let's write it here. It's a decreasing queue, and all numbers are satisfy index. Let's say index should be less or equal to I minus j, I minus k. Okay, so the first step is to pop friend all the members that do not satisfy this condition. So while k is not empty, and q top front is greater than I minus k, we will pop it. Okay, and suppose this queue is decreasing, which means the first element of this queue is the maximum element, right? So what we can do is first fi, it can be equal to namesI, right? This is one of the choices. And if the queue is not empty, then fi can be the max of fi and the front element in this queue. It is q front and plus nami. Remember that the index in this queue are for the f. Although they are identical to names, but don't confuse them. It means that the value of f are kept decreasing inside this queue, so that we get the element for f, then plus names I. It actually means between this number and this number I, all the numbers in between are deleted in our case. Okay, so after this, we got the value of f, so we can update res. It's max of res and f. Then we need to maintain the queue decreasing. How to maintain the queue a decreasing queue? So we check all the elements from the back. If the elements on the back are less than the current element, then we can pop back. Okay, so after we pop back, we can add this element into this queue, q, and push back I. Okay, and I think that's it. We can just return res. Let's try. Oh, we didn't define n. N is size of names. Q. Oh, this is a DQ, so we pop friend. Let's see what's happening here. So we have this one, Q friend, should be I think this is less than, right? This is not larger than, this should be less than, because we need to satisfy this condition. So this means Q friend and minus Q friend. Q friend is actually I here, right? Q friend plus K larger greater equal to I here. So we should make it, if it's less, then we should pop it. Okay, it seems it's working. Let's submit. Okay, it passed all the test cases. So I think this is also a pretty hard question, because this step is something everyone, I think, if you are familiar with some medium level question, you will be able to come up with this solution. However, you need to optimize it with this either decreasing array or priority queue. This is something very hard to think about it. And I think that's it for this problem. Thank you for watching. See you next time.